Relative age rock layers assignment. The most recently formed rock unit is at location. I see a pattern of limestone, shale, sandstone, limestone, shale, sandstone. So I'm going to assume that these three go together. That makes this number 1, the first layer. This is actually underneath here. I can't see it. This makes this number 2, number 3, 4. On the other side here, this would be number 2, this would be number 3, this would be 4, this would be 5, and by the way, this would be 5. What I notice is that the fault cuts through the rock layers, but it doesn't cut through the igneous intrusion, so the fault is actually number 6. Number 7 is the igneous intrusion, which you can see cut through the other two, also has the contact metamorphism. So the most recently formed rock unit is letter D. Number 2, the geological cross-section below shows sedimentary rock layers. This would be number 1, 2, 3, 4. That matches up over here. And the igneous intrusion goes over the fault. That means that the fault would be number 5, and the igneous intrusion would be number 6. The most recent event then would be the igneous intrusion. Which rock group contains the oldest layer? The oldest layer would be located at the bottom based upon the law of superposition. The Clinton group is our correct answer. The unconformity between the Paleozoic sediment rocks and the Precambrian rocks represents an unconformity represents a period of time in which you had uplift, you had erosion, you then had subsidence and new deposits. That means part of the rock record is eroded away. That leaves a gap in the geological time record. Which Paleozoic rock is the oldest? The oldest rock would be found at the bottom, number 1. The geological evidence shows in the diagram indicates that rock S is younger than rock T. This is an igneous intrusion, and we can see contact metamorphism, which means that rock T had to be there before. Rock T is located nearer to the top of the layers, so therefore it is younger. One thing really stands out amongst all these choices. Rock R has a fault that runs through it, and in order for a fault to run through something, the rock has to be older than the fault. So letter D is our best choice. Which of these events occurred most recently at this location? This would be a matching up of layers. This one here would actually be number 1. This would be 2. This would be 2. This would be 3, 3, 4, 4, 5. Little piece of 5 left over here. 6. Then we have an igneous intrusion and a fault. This time the igneous intrusion is cut by the fault. So the igneous intrusion would be number 7. The fault would be number 8. Faulting along line XY. Which event occurred before the formation of rock layer B? Weathering of rock layer A. Rock layer A is above B, so that had to happen after. Faulting of rocks along JJ prime. That fault happens underneath. That must have occurred before the formation of B. Intrusion of igneous rock layer H. H passes over B, which means B had to be there already. Formation of metamorphic rock along layer A. That metamorphic rock over here from the igneous intrusion had to happen after B. Igneous rock B was formed after rock layer D was deposited, but not before rock layer A was deposited. Using contact metamorphic symbols shown in the key, draw the symbols in the proper locations on the cross-section provided to indicate those rocks that underwent contact metamorphism when igneous rock B was molten. We know that D was there before, so we'll have contact metamorphism happening at the bottom here. Rock A was not even there for that contact metamorphism to happen. Which statement gives an accurate age relationship for the bedrock in the cross-section? Intrusion A is younger than intrusion C. Intrusion C causes intrusion A to have contact metamorphism, therefore intrusion A had to be older. Intrusion C is younger than intrusion B. Intrusion C cuts across intrusion B, meaning that intrusion B is younger. Intrusion C is younger than intrusion B. Intrusion C cuts across intrusion B. That is the correct answer. Intrusion B is older than intrusion A. Intrusion B has contact metamorphism with intrusion A, therefore intrusion A has to be older. Intrusion C is older than intrusion E. Intrusion C goes over layer E, therefore layer E had to be there before, it had to be older. Number 11, which statement correctly describes the relative ages of rocks A and C and gives the best supporting evidence? The correct answer is B. A is younger than C because the intrusion of A metamorphosed layer C. Rock B is most likely which type of igneous rock? Rock B is formed on the outside. It's an extrusive igneous rock. Looking at the reference table, we'll find that of the choices here, only one type is an extrusive igneous rock. That would be basalt. Granite, peridotite, and pegmatite are all intrusive. Which rock feature is the oldest? Rock G, found at the bottom, would most likely be one of the first features, so would be the oldest. And since it's cut by the fault must be younger. And since there's an unconformity on top of that must have happened afterward. Correct answer would be rock G. The unconformities shown in the cross-section represent buried erosional surfaces. Number 15, the movement of bedrock along fault Q most probably produced when there's a movement along a fault, usually produces an earthquake. Which sequence of events most likely caused the unconformity shown at the bottom of layer B? And an unconformity occurs when we have that uplift. After we have uplift, we have erosion, we have deposition. So the unconformity would have happened during a period of time of crustal movement, maybe some pressure between two plates causing some folding, then uplift. Once there it was uplifted, it was eroded, and then after that, subsidence occurred and new deposition. Number 17, the folding of rock layers G through C was most likely caused by, when we see folding like this, it's usually caused by tectonic pressures between two plates colliding. Number 18, the metamorphic rock at location A is most likely. We look at this type of rock here. This is a sandstone. And when sandstone undergoes contact metamorphism, it will change. And according to the reference table, the metamorphism of quartz sandstone results in quartzite. Which sequence places the rock layers and the fault from order of oldest to youngest? So we know we have to start with this being the oldest, 2, 3, 4. 2, 3, 4. The fault would be the fifth thing here. Letter A would make the most sense. If the granite intrusion occurred 24 million years ago, what are the most probable ages of the schist and the shale in millions of years? So since the intrusion is 24 million years old and the schist has contact metamorphism on it, that means the schist has to be greater than 24. And since the shale has no contact metamorphism on it, that means the shale is younger, which has to be less than 24. So the schist has to be less than 24, so the schist could be 25, and the shale has to be less than 24, so the shale has to be, so the shale could be 23. Which characteristic of the granite intrusion provides the most evidence that it's solidified deep underground? When an igneous rock is forming deep underground, it has time to cool slowly, and that provides it with time to form large crystals. An igneous rock with large crystals is said to have a coarse texture. Which event occurred sometime after the formation of the unconformity, which is, here's the unconformity. The formation of rock unit 3 is above the unconformity. It must have occurred after. Number 23, which rock most probably formed in the contact metamorphic zone within rock unit 6? That's this unit right here. I see that symbol as shale. Marble forms from limestone. Basalt is an igneous rock. Quartzite forms from sandstone. Hornfelds from a variety of rocks that undergo contact metamorphism. Which rock unit is the youngest? This would be 1. This would be 2. And now, because this has no contact metamorphism on the top, this igneous intrusion came to the surface, spilled over. This is number 3. And then after, number 4. I can tell because there's no contact metamorphism that this layer was not there before. Which rock layer is the youngest? It would be rock layer A. On the cross section, draw a dark line to indicate the most likely location of the unconformity. And what you see here is you see the folding of the layers, and this layer is truncated, the fault disappears right there, and then you have a flat layer on top. Here's where you're likely to find the unconformity. What evidence indicates that the folded bedrock is older than fault line XY? Fault line XY cuts across the folded layers. Identify one metamorphic rock that would likely be formed in layer G along the igneous intrusion. Since layer G is a sandstone, when sandstone becomes metamorphosed, it turns into quartzite. The fault most likely occurred after layer B formed. You see it cuts through layer B, but before layer C. At which location is quartzite most likely found? So we know that quartzite comes from the metamorphism of sandstone. Here we see shale against here, and we see limestone, but here we see sandstone, would be letter C. In the box that represents box A on the cross section below, draw both the volcanic ash layer and the basalt intrusion to clearly show their relative age. So when I draw this through, I know that the layer of volcanic ash would have been cut by the intrusion here, and the intrusion would have cut over like this, and we would have that, like something like that. So we know that the igneous intrusion cut across the layers, so it would have cut across that volcanic ash layer too. Describe one piece of evidence that indicates that the horizontal rock layers are younger than the tilted layers. Now you'll notice that the horizontal rock layers are on top of the tilted layers. We could say that the horizontal layers are above the tilted layers. What evidence shown in the cross-section indicates that the basalt rock unit is the youngest rock unit? And this basalt layer goes all the way, it cuts across all the other rock layers. Also, we have the contact metamorphism